Assalamu alaikum class. In today's lecture, we will learn about the E by M ratio calculated by J.J. Thomson. We will also learn about the Millikan methods to find out the charge of an electron. Then mass of electron calculations will be done. Discovery of anode rays and their properties will also be discussed. The first objective is the measurement of charge to mass ratio of an electron. For this, J.J. Thomson performed an experiment by using a beam of cathode rays to see the effects of electric and magnetic fields on it. Right? This experiment was performed in 1897, by which he calculated E by M ratio of an electron. This is the apparatus used by J.J. Thomson to perform his experiment to calculate the charge to mass ratio of an electron. You can see it is discharge tube which consisting of a cathode and anode supplied with the battery, and here it has the two electrodes which are applied here, that is electrical field is applied on it, and then there is present a bar magnet which is placed around it. It is a circular one magnet actually which is applied over there, but not at the same time they are applied one by one. The two fields are applied, that is electric and magnetic field. Here there is present a screen, that is a fluorescent screen. When the cathode rays will strike upon it, it will become bright. Right, it will show you the spot at which the cathode rays are striking. Right, Ji? Now here the experiment is done in such a way that cathode rays which were coming out of this cathode, when they pass through anode, as it has a hole in it, they, without the application of the two fields, that is electric and magnetic field, in their absence, they are not under the influence of any field, so they strike straight at point B on this fluorescent screen. But when we apply one of the field, that is only electrical field, then what happens, as it carry the poles in it, and you know very well that cathode rays, they are composed of electrons in them, they are negatively charged, so they move towards the, or they bend towards the positive plate of the electrical field. Here it is, that is on the upward direction, they will strike at point A. Right? Then if we apply the magnetic field separately without the influence of electrical field, the ray will bend towards point C under the effect of magnetic field. Right? And if we apply both of these, the electrical and magnetic field simultaneously, collectively, इकट्ठा दोनों को अप्लाई करें और इनकी स्ट्रेंथ्स को इस तरह से एडजस्ट करें कि एक का इफेक्ट कैथोड रेस पे दूसरे के इफेक्ट को कैंसिल आउट कर दे, then no more striking at A and C of cathode rays, but they will, without the influence of E and that is electrical field and magnetic field, they will again strike at point B. Right? So the two fields, they will cancel each other's effect. The E by M ratio then by calculated by means of the electrical and magnetic fields when they were adjusted by comparing their strengths, the two fields, he determined the E by M ratio. Here only the value is given, so there is no requirement to find out it by calculations. Here the value is given, it is 1.7588 into 10 raised to the power 11 coulombs per kg. Right? Here E means charge is 1.7588 in 10 power 11 coulombs, while the mass is 1 kg. It means that 1 kg of electrons, they have 1.7588 into 10 raised to the power 11 coulombs of charge on it. Right? So this is the E by M ratio calculated by J.J. Thomson. Now here is the experiment which is given by Millikan for the measurement of the charge on electron. A diagram is given for the apparatus. Millikan constructed it to find out the charge on an electron. The experiment is called oil drop method, performed by Millikan in 1909. This apparatus consists of two chambers, the upper one chamber and the lower chamber, separated by an electrode and metallic plate. In between the two chambers, this metallic plate will also behave as an electrode, same as is the lower one plate, which will also behave as an electrode. Right now, the upper one metallic plate, is having a small hole in it for the movement of the gas oil droplets. Here, this one is the atomizer. This atomizer will help to spray the oil droplets within the chamber in the form of a mist. These oil droplets now will move under the influence of gravity downwards in the lower one chamber due to the presence of a hole in the upper chamber. Now here there is present a microscope adjusted in the lower one chamber to see the movement of the oil droplets within this chamber. Here there is applied the electrical field. This will show you that how much electrical field is being applied. It will give you the strength of this field. Right along with it, inside this whole chamber, there is present the air particles at a very low pressure, so that these particles, they will be ionized by means of a source of X-rays, which will be bombarded on these particles. Right, this is the whole apparatus or the whole instrumentation which is done for this experimentation. Now what happens in it, how the experimental activity is done? It is the atomizer which will spray the mist of the particles within the upper one chamber. These particles, under the influence of gravitational field, they will move downward by means of the hole in the lower chamber. Right, as they are without any influence of the electrical field, so they will move downwards. If the gas particles in this chamber, they are ionized, the electrons will be ejected out from these gas particles. These oil droplets will capture these electrons, so that they will become charged, or they will acquire some charges on them. That can be the unit charge, that is single electron is absorbed by the oil droplet, or maybe they are going to absorb more than one, right, in the form of the multiples 2, 3, 4, 5, etc. Right now the electrical field is applied. This electrical field will stop the movement of the particles, so their velocity, which was first v1 without the electrical field, it was v is equal to mg, that is according to their mass, is the product of, that is velocity is the product of their mass and gravitational force. Now the when this electrical field is applied, it will nullify the effect of this gravitational force. It is so adjusted that the particles would not only move upwards, but they will stop within it, that they become suspended, so that now their movement can be measured quite easily. What is the charge upon them is then calculated. The observation is done with the help of the microscope. Then the unit charge which was found on a simple one droplet was found to be 1.602 into 10 to the power minus 19 coulombs, as it was calculated. Now the charge on it can be on the other droplets, it was found it is in the form of the multiples, that 2 into 1.602 means more than one electron is being taken by the particles. Now here on the next one, there is given a video which will support this measurement of charge on electron. Right, it will also give you how to calculate the mass of an electron by using E by M ratio given by J.J. Thomson. Okay, now this is the experiment performed by the Millikan, that is Millikan's oil drop method, in the form of an animated video.
Millikan's oil drop experiment. British physicist J.J. Thomson had measured the ratio of electrical charge to the mass of an electron using a cathode ray tube in 1897. Later, R.A. Millikan looked to determine the charge on the electrons. The famous method that he devised between 1906 and 1914 to measure.
Here the determination of mass of electron is being given, that how to calculate the mass of an electron. This is the E by M ratio, which was calculated by J.J. Thomson. That is 1.7588 into 10 per 11 coulombs per kg. Now, charge on an electron is being found by Millikan's oil drop method. That is 1.602 into 10 per minus 19 coulombs. When it is arranged like this, E by M is equal to E by M. This one, E by M, right? Becomes wrong. Let me to change it again. E by M, right? Now, this is the E by M ratio placed here, this one, while here in it, this is E, you have to calculate this M, right? So rearrange the equation. You will get the mass of an electron, that is 9.1095 into 10 power minus 31 kilograms. Similarly, an other numerical is given, a solved one. How much heavier is the hydrogen atom as compared to an electron? Beta, both of these can be asked as the 3 marks question in section B, right? Mass of an hydrogen atom is 1.67 10 power minus 27 kilograms. It is given in a table in the book. Mass of electron is 9.11 10 power minus 31 kilograms. So divide to get how heavier the other one is. So it is 18331 times heavier than that of an electron, right G? Now here there is given a diagram for an experiment which is given by Eugene or performed by Eugene Goldstein in 1886, who found or who discovered proton by this experiment. This is the experiment which is called the canal rays or a positive rays experiment, for which a glass tube is used. Again, the same is the instrumentation as we use for the electron discovery or the cathode rays discovery. We have a glass tube which have 2 electrodes in it. This time the cathode, that is perforated one. Perforated one means it has holes in it. Here you can see this electrode is having holes in it. Now there is present some air particles or some gas within it, right? But at a very low pressure of 0.01, a high voltage current will be applied, whose strength may be in between 5,000 up to 10,000 voltage. The rays which are coming out of the cathode, when you supply it the electrical current, so what happens, the rays which are coming out in the form of the cathode rays, they strike with the gas particles within the chamber and they ionize them. When they ionize them, the electrons which are ejected, they comes again along with that of the cathode ray particles, as they both have the same charge, but the gas particles left over after the discharge of electron from them, they appear as the positive charges, right? After the loss of electron, they acquire positive charge on them. This charge can vary with respect to the gas which is filled inside, right? For example, if you say hydrogen is placed, it can each hydrogen atom can lose 1 electron, but if we have placed oxygen in it, each oxygen atom can lose 2 electrons, right? So the 2 positive charges or 1 negative charge, 1 positive charge may be acquiring the gas particle on it. these gas particles, they will move towards the cathode, which shows that these gas particles are now positively charged. As this cathode is perforated one, so what happens, they pass through these perforations by means these holes, and they are collected behind this cathode, right? Now here, this one is the experiment which was performed. What observations were made through this experiment? In it, you can see here the two diagram and two what you say, the equations are given, that m, that is any gas particle in it that is losing electron and converting into M plus sign. An example is given as helium will lose 2 electrons and will convert into He plus 2, right? So what the properties were found there? Achha, before this, there is another short question, that why they are called canal rays. They are called canal rays because they pass through the perforations or the holes which are present in the perforated cathode, right? So that's why they are termed as canal rays, right? Or otherwise they are also called positive rays, as they have charge upon them, that is unit positive or maybe multiple of this, right Ji? Now here's the Goldstein who performed this experiment. Here is the video attached with it. Okay, so you can understand it well. Now these are the properties of anode rays. Anode rays, they are called as they move away from the anode. They are not produced from anode, but they are produced from the gas particles. But due to the similar nature, as anode is holding positive charge, these particles will also hold the positive charge, so they will move towards that of the perforated cathode. Now what the properties are there? Anode rays travel in a straight line, same just like that of the cathode rays. These rays, they are deflected by electric and magnetic field. If you perform the same experiment we did for the electrons, those, so they will also be deflected in the electric and magnetic field. In electric field they will be deflected towards the negative pole, and same is here in the magnetic field. Now it shows that these rays, they are positively charged particles, so the rays, they are attracted towards that of the negative plate of the electric field, as I told you now, so which confirms that these particles, they are positively charged. And third point is, these rays, they consist of the material particles. As I told you earlier, in the previous one experimentation, we found that these material particles, they are capable to rotate the a small pedal wheel due to the energy present in them. As they are material particles, when they strike it, they are going to move it, right? Now the next one is anode rays. They produce heating effect when they strike to the wall of the container, or you say the metal or foil पे जब भी they are going to fall, they are producing heat. उसको heat up कर देंगे, गर्म कर देंगे, right? The ratio of charge to mass for the positive rays is considerably smaller than for the electrons, क्योंकि इनका mass ज़्यादा है और इनका जो electrical जो charge है इनके ऊपर, that is similar to that of the electron, लेकिन mass इनका जो है वो variations के साथ आता है. So that's why इनका जो आपके पास में charge to mass ratio due to the mass larger होने की वजह से that will be smaller than that of an electron, and it is also not constant. As I told you earlier, अगर हम हाइड्रोजन ले लें तो हाइड्रोजन का mass तो 1 है, लेकिन अगर हम हीलियम ले लें तो हीलियम ions after losing 2 electrons, the mass उनका जो आ जाएगा वो ज़्यादा होगा as compared to that of hydrogen. और जब आप उनका mass रखेंगे as a denominator, तो definitely ये आपके पास में वैल्यू, क्योंकि चार्ज तो वही रहेगा, तो वैल्यू जो है E by m की वो और रिड्यूस होती चली जाएगी, राइट? तो जो नेचर है गैस पार्टिकल्स की वो एक्चुअली डिसाइड करती है कि E by m रेशियो पार्टिकल्स की क्या होगी, और ये गैस टू गैस वेरी करेगा, राइट जी? जो भी गैस आप इसके अंदर प्लेस करेंगे इट विल वेरी the E by m ratio, right? The simplest one or the lowest one जो रेशियो आपके पास में जो हाईएस्ट वन रेशियो कैलकुलेट की गई है, दैट इज फॉर हाइड्रोजन, क्योंकि उसका जो मास है वो सबसे लोएस्ट है विद इन द एटम जितने भी हैं, राइट जी। नाउ